The measure of angle YZH, so that's this guy, right? Is negative 5x minus 13. So we'll write that in. Negative 5x minus 13 degrees. The measure of angle HZS, so that's this angle up here, is 9y minus 8 degrees, right? The measure of angle SZB, so that's this guy down here, is minus 9x minus 73 degrees. So they want us to provide the value of x, and they want us to provide the measures of two angles. Okay, and it'll vary the ones that you get. It's going to be different from person to person, but they're all going to be the same idea. So how are we going to do this? What do you think?
Make a linear system.
Okay, maybe we're going to make a linear system. It might end up being that way, but just before we even get to that point, we're just going to have to come up with some equations, aren't we? Right? We're going to have to come up with equations that allow us to solve for x so we can plug it back in. To get those equations, we're going to use some geometry relationships. Yes, Nick has an idea.
You can set negative 5x minus 13 equal to negative 9x minus 73.
Good. Very good. Now, what are our relationships here? We know that if I'm just, let's call these angles real quick, just so we don't have to say so many letters and things. Let's just call this upper right angle. We'll call that angle 1. We'll call this angle 2, and we'll call that angle 3. Why can you do that, Nick? How come angles 1 and 3 are congruent, so they have the same measure?
You just set them equal because they're the same.
Okay, but what's the, you guys remember what the relationship is? What do we call it?
Oh.
Vertical angles? Okay, good. So they're vertical angles, so they are congruent. Good. So we can set their measures equal, and that's a great idea. And we'll talk even more about why that's a good idea. What are some other relationships that we potentially have up here if we want to come up with an equation? Yes, Tyler?
Angle 2, when they're, what did that angle 4 down there equal to?
It would. Okay, so if we call that angle 4, those would also be vertical angles. We don't know anything about angle 4, though, so that one may not help us so much, right? But is there a way we could link angle 2 to one of these other angles in a relationship? Yes.
The x, 1 and 3.
Okay, 1 and 3 would be equal. Could we link these two?
Oh,
Yes.
1 and 2 equal 180.
Okay, good. 1 and 2 are what? What do we call those if they're adjacent angles that form a line? They're supplementary, but you're right, they're supplementary. What do we call that relationship, though, in that case? To, what is it? Linear pair. Good. Remember linear pair. So let me quickly just review that. A linear pair, if I have two angles like this, so that, you know, here's one angle and here's one angle, they share this side, don't they? Right? They share one side and they share a vertex. If the two sides that they're not sharing, which we call the non-common sides, if they form opposite rays, which we can think of even better as being a line, right? If the two non-shared sides form a line, then we call that a linear, there's the word line, linear pair. And we know that they're supplementary, so their measures add to 180, right, every time, okay? So if that's the case, then we could say that the combination of those two add to 180, right? Now, I think Nick's idea was a much better idea there. How come? If I say this expression plus that expression equals 180, what's the problem with that?
There's 2 variables.
Yeah, there's two variables. I've got x's and y's, right? That makes it harder. We'd rather have an equation with one variable if we could. They're much easier to solve, right? So Nick had a great idea. Let's just set these two equal to each other, those measures, and solve. Let's do that. So if we do that algebra, if we set negative 5x minus 13 equal to negative 9x minus 73, now we can just shift into algebra mode, right? We harnessed our vast knowledge of geometry here to come up with the relationship that gives us an equation. Now we just solve it. So what are we going to do to solve that? We're going to simplify. Okay, so what are some things we can do there? Say it again. We could add 5x, that's fine. If we want to be really particular about this, maybe we wanna add 9 instead. Why do you think, Tyler, why might we add 9x instead of adding 5x?
So it'd be positive.
So it's positive, right? So we'll always put the variable on the side where it'll end up being positive. Not a big deal, it'd work either way. But if we add 9x, those cancel, so on the left side, I'm gonna get a 4x. Well, while we're at it, what do we wanna do with the numbers then? If the variables are going left, where should the numbers go? Right, because we're trying to isolate x, aren't we, right? So we could, what do we do then? Add 13. We could make those separate steps, but you don't need to. Make them the same step, combine them. So now the numbers are gone from the left. On the right side, the variables are gone. What do we get for numbers? What's negative 73 plus 13?
60.
Negative 60. And remember our rule for that. I think there's been a little bit of question about that, about where that comes from. You know, how do we add positives and negatives? Remember, all we do is we just subtract the two numbers, ignore the signs, subtract the smaller from the bigger, and keep the sign of, like in this case, if we ignore the signs, they're different signs. What's 73 minus 13? 60. And is it gonna be positive or negative? Negative, because the negative number was bigger, right? Good. So 4x equals negative 60. What do we do next? Divide by 4. And so we get x equals negative 15, right? So now really that gives us a lot of stuff. If x is negative 15, they want to know what's the measure of angle YZH, right? So what do I have to do to find that? Plug it in. So I'm going to get negative 5 times negative 15 minus 13. Well, negative 5, negative times negative is positive, right? 5 times 15 is what? Thank you, sir. There's Trinity. Oh, she's not here? Okay. Hey, you know, she's not here. Okay, so 75 and then minus 13 gives us what? 62, good. So we got that answer, don't we? So this is 62 degrees. Now we could, if we wanted to, and maybe you can find a shortcut here. We know that this whole angle now, we could essentially erase all that stuff because we know what it is, right? We used x to find out what it was. So if this one is 62 degrees, what's that one down there? 62. So I could even replace all that stuff with 62 degrees. We could set up a pretty easy equation to solve for y, couldn't we? Right? If we needed to solve for y, what could we do? Yeah, those form a linear pair, don't they? Right? Plus, right? Does that make sense? They form a linear pair, so those two angle measures have to add to 180. So there's our equation if we needed it. 9y minus 8 plus 62 equals 180. Solve for y, right? And plug it back in. But do we even really need to solve for y here? No. We don't, do we? Because look what the question's asking. It's asking for the measure of angle HZS. Maybe we don't even need y. If this angle has a measure of 62, what's the measure of that angle? 118, because that's what? Yeah, that's 180 minus 62, right? These two have to add up to 180, so we could really take a shortcut here, couldn't we? We could just say we don't even need that stuff because these add to 180. That's 118 degrees, and that's our other answer, right? Make sense? Okay, so now let's look at one more. Okay, this is the same kind of deal. I'm not even going to put the picture up here. It's the same kind of picture though, right? So think of this as being, this was like angle 1. I'll put those letters up. So this was like angle 1, that was like angle 2, and that was like angle 3, right? So here's kind of our picture. I guess it looks something like, something like 1, 2, and 3, right? Okay, so same kind of a situation. Why is this one harder though? Yeah, okay, look at all the expressions. The expressions that tell us the angle measures, they all have x's and y's. So we don't have, this time we can't use Nick's trick. We can't just say, okay, let's just pick the two easy ones that have only x's or only y's, right? We're stuck. But we still have the same kinds of relationships, don't we? What's the relationship between the measures of angle 1 and angle 3? They're congruent because they're vertical angles, right? So would everybody agree that's one equation we could set up? We could say that the measure of angle 1 plus equals. Oh wait, there we go. Equals the measure of angle 3. So those two we could set equal, right? That gives us an equation. Let's do that. So if we set those up, we're going to get 6x plus 5y plus 181 equals negative 4x plus 2y minus 51, right? Okay, now where are we going to go with this? We've got two, would you agree, kind of looking ahead a little bit, and as you get better at math, you develop the ability to kind of think ahead, at least just a little bit, right? Can you sort of envision here that as we do this math, when we combine like terms and do all that stuff, we're going to get both x's and y's in our answer, aren't we? Okay, so that means this is the most important rule in algebra. I'm sure this was just hammered home last year and the year before. I've mentioned it this year, but I'll keep hammering on it this year. This is it's called a fundamental rule, theorem of algebra. Right? All this says is that the number of variables that you have that you're solving for tells you how many equations you need to have also, right? It's worded a little differently, but because I've got two variables here, x and y, I need two equations at a minimum to be able to solve, right? So there's going to be one of my equations. What about the other one? Well, we'll get to that. But we're going to end up with a situation kind of like what we had before in the algebra review that we did earlier in the year. Remember all those problems where you solved linear systems, where you had stuff kind of like this maybe, right? And we had to solve the linear system. How did we do that? We really had two strategies. Okay, we could use elimination. I think most of the time we use elimination, right? Where we've got to multiply, one or both of the equations by something so that we can get the x's or the y's to cancel, right? In this case, if this were our problem, going back to the review, what could we multiply maybe the top and the bottom by to get things to cancel? Like say we wanted, the x's have pretty small numbers. Let's say we want to get the x's to cancel. What could I multiply the top by? I could multiply the top by 3, okay. And the bottom I could multiply by -2. And the whole reason for doing that would be, in the top equation, I would get 6x plus some other stuff, right? And on the bottom one, I would get what? -6x plus stuff. And the whole reason I do that is so the x's would cancel, right? And I'd be left with just y's, okay? What I want you to notice about this is the way that we always wrote, or I guess they were written for us, but the way that the linear equations were always written. They were always written in this form. A number times x plus a number times y equals a number. That's what we call standard form for a linear equation. No big deal. Where just a, b, and c are just integers, positive or negative whole numbers, right? So that made it easier for us to solve for the system, right? So going back to the problem we're working on now, let's get it like that, right? Let's get this equation that we took by setting angles 1 and angle 3 equal to each other. Let's turn that into standard form. It's not difficult. What do? We want to get the variables on the left, and the number on the right is really all it was, right? So what are we going to do?
Add 4x to both sides.
Okay, I'm going to add 4x to get the x's off of the right side. What else?
Subtract 2y.
Good. Subtract 2y to get the y's off of the right side. And where do I want the numbers to go?
Subtract 180.
Yeah, I want the numbers to go to the right side, right? So I'm going to subtract 181 so I get rid of the numbers on the left. And then I just end up with what? So I get, what's 6x plus 4x? 10x. 5y minus 2y equals negative 51 minus 181. Same thing as negative 51 plus negative 181. Yeah, negative 232. There you go. So there's one equation, right? That looks like another one. Okay. Alrighty. So there's one equation that we need. It's in the right form. Something times x plus something times y equals a number. We're going to call that equation 1 and save it for later, right? Halfway there, but we need another one. So what's another geometry relationship that we could use here? We set 1 equal to 3. What's another way we could go? What do you think?
1
1
plus 2
plus
equals
2
180.
equals
Sure, right. 1 and 2, these two angles here, they form a linear pair, don't they? Right? So their measures should add up to 180, right? So let's do that. The measure of angle 1 plus the measure of angle 2 equals 180, right? Come up with that equation. So what's that look like? So that's going to give us negative 4x plus 2y minus 51 plus this guy. So 5x plus 6y plus 131 equals 180, right? Okay. It looks like a lot of stuff, but it's no big deal. We're just going to simplify, combine like terms, right? So once again, we want to get the number, or the variables on the left and the numbers on the right. So what are we going to do? Simplify, yeah, combine like terms, right? Negative 4x plus 5x is what? Everybody agree that's 1x? Negative 4x plus positive 5x is 1x. So let's just sort of cancel these out as we go. So we know those guys we took care of, they became 1x. What about the y's? 2y plus 6y is 8y. Okay, so we combine the y's, so they're taken care of. Now, what about the numbers? What's negative 51 plus 131? Same thing as subtracting, right? So 80. And you can, and the numbers are big, but don't be panicked when you see, you have calculators, right? I mean, don't worry about the big numbers are no big deal. Just a couple more buttons to push. So plus 80 equals, and now we've taken care of those guys, equals 180, right? Last step, to get this to look like we want it to. Subtract 80, right, because we want the variables left, numbers right. So we'll just subtract 80 from both sides and get x plus 8y equals, what's 180 minus 80? 100. So there's equation 2. That looks like a linear system, right? That's the same kind of stuff we dealt with during the algebra review. We've got two equations, two unknowns. Now we got a bunch of ways to solve this. Let's go ahead, I'm going to rewrite these just so it looks better, and then we'll just focus on the algebra for a second, and then we'll be done with this. So we got, our system is 10x plus 3y equals negative 232, and x plus 8y equals 100, right? Suggestions. What are some ways we could solve this? Okay, we could multiply the bottom by negative 10, so the x's cancel, right? That's fine. That would work great. Any other ideas? Is that what you're going to say, Sean? Okay, we could. In this case, substitution actually is maybe not a bad idea. How come? Okay, big numbers, and also look at the bottom. There's an x value that's really easy to isolate, isn't there? What's the only thing I have to do to get that x by itself? Subtract 8y. Okay, good. So we come up with we can easily come up with the substitution equation. X equals, if I'm going to subtract 8y from both sides, on the right side I'm just going to get 100 minus 8y, or I could say negative 8y plus 100, doesn't matter, either way. Put a box around it, because that's my substitution equation, right? Now what do I do with that one? Once I've solved for a variable in one of the equations, how do I do, what's the substitution approach? Substitute, exactly, yeah. So in the other equation, every place I've got an x, I'm going to plug in that, right? Okay, so what does that give us? If I do that, I'm going to get 10 times the quantity 100 minus 8y. So there's my 10x, right? Plus, everybody see that? All I did was I just put that x right there, right? Plus 3y equals negative 232. Those are big numbers, but don't worry, don't panic. It's not a big deal. They're just numbers, right? It's probably getting hard to see. Let me go to another page. How about? So what are we going to do to simplify here? What do I do? I got to solve for y, but it means I got to simplify first. Suggestions? Shall we think?
Distribute 10.
Distribute the 10. Good. If I distribute the 10 all the way through, okay. Maybe yeah. Might say immediately. Doesn't. Why don't you go check though? Oh, I got you. Okay, you're fine. Yeah. Okay, so if I distribute the 10, what's 10 times 100? 1,000.
Nice, Justin.
10 times negative 8y plus 3y equals negative 232. What's left? What do I do here? Combine like terms. So negative 80y plus 3y is what? Negative 77y, good. Get 1,000 minus 77y equals negative 232. Don't panic, big numbers, who cares? Cassidy, what are going to be the 2 steps in order I'm going to have to do to get to y by itself? What do I need to do first? Subtract 1,000. Good, gets rid of that term. Then what? Divide by negative 77 and we'd have it, right? Okay, so let's do that. If I subtract 1,000 from both sides, those go away. I get negative 77y equals negative 1232, right? Negative 232 plus negative 1,000 is just negative 1,232. Last step, divide by negative 77, and negative divided by negative is positive. That's got to be 16. Is that right? Somebody have a calculator? Is that 16?
How did you do that?
Don't even know.
Okay, so we got y, right? Right, we got y. Now, what do we have to do to find x? If I know that y is 16, go plug it in, right? Plug it into my substitution equation and see. So if y is 16, then x is just going to be what? X is going to be 100 minus 8 times 16. 8 times 16 is 128. 100 minus 128 is negative 28. And, you know, calculator can get through this stuff too. It's no big deal. So now I know x and y. Really, from this point forward, we're done, aren't we? If I know x and y, those are 2 of my 3 answers, and the other one's a piece of cake. What do I do to get the other one? Plug it in, right? Does that make sense? And we got it. Okay? All right. Go. Grab the phone book and get going.
Wait, Eight.